La emisión está comenzando. Todos los asistentes están en modo de solo escucha.
Hello, everyone. It's a pleasure to greet you and to welcome you on behalf of the NBSAP Forum to this first webinar of the Introduction to Resilience for Development MOOC, offered by the United Nations Development Programme. My name is Marcela Torres, and I'm a consultant on sustainable development and green economy. I will be your facilitator throughout the entire course. We are grateful for your participation in this first webinar, titled The Power to Change the Earth System, the Anthropocene from a Personal Viewpoint, which will be offered by Dr. Sarah Cornell. Dr. Sarah Cornell is a global change researcher at the Stockholm Resilience Centre, Stockholm University. Her background is in marine and atmospheric chemistry, but for nearly 20 years she has worked towards sustainability in transdisciplinary and integrative ways. Her research bridges across physical and social sciences, using methods from Earth system science and social ecological resilience. She engages actively with governance processes ranging from community action and business strategy planning to international policy on climate vulnerability and risk, biodiversity loss, nutrient use, and pollution. In this webinar, she will briefly describe why and how scientists view our Earth as a system and discuss what that means for our understanding of global change processes and our capacity to intervene in them. She will also address the distinction between hitting limits and respecting boundaries, reflecting on biophysical processes, societal activities, and the place of knowledge and engagement in navigating sustainable pathways. Finally, she will cover some of the pressing questions that we currently face. How do we deal with urgent environmental issues? How do we deal with social differences? How do we deal with different value systems? Welcome, Dr. Sarah Cornell, and thank you for accepting this invitation. It's a pleasure to have you here today.
Thank you very much. It's a very big pleasure to be here as well, and I'm really looking forward to the discussion and to the questions that we'll have at the end of my presentation.
Thank you. Before we begin, I would like to remind all of our participants of some rules and dynamics in the NBSAP Forum webinar sessions. Microphones will be muted during the presentation. This reduces interferences and facilitates communication. We will have a 30-minute presentation followed by 30 minutes of questions and answers. Please send us in advance your questions or raise your hand in the control panel of GoToWebinar. If you want to speak and the connection allows it, I will open the microphones during the Q&A session. This session is being recorded and it will be available on the NBSAP Forum website, www.nbsapforum.net. All participants will receive an email with a link to watch it as well as a PDF copy of the presentation and a list of resources related to the topic. Don't forget to visit our YouTube channel to watch this or any of our previous sessions. Now I will transfer the webinar to Dr. Cornell. We hope you enjoy this session.
Thank you. Hello, everybody. Right now, in my scientific world, there is a lot of attention to the idea of the Anthropocene, the recognition that we as human beings have the power to change the way that the whole planet works, the way that it works as a system. And one of the questions that has really focused my own research for the last few years is, what is our place as individual human beings when collective humanity is changing the Earth system? So I will give you an overview of what Earth system change means, but I really want to engage in the discussion with you all about what global environmental change means in the context of personal responsibility for global sustainability. The first thing to do is to really explain what we mean when we talk about the Earth system. And I've already moved one slide forward too fast. if you go back to the picture on my title slide, you can see that many global change scientists view the whole Earth as the dynamic interconnections of the living world, the atmosphere, the oceans, the solid Earth, in other words, the rocks and the tectonic plates beneath us, and very importantly, the ice sheets as well, because they serve an important function in shaping the climate system and stabilizing the climate through feedbacks. This idea that we can think of the whole planet almost as a very large organism, where the chemical and biological and physical processes interact and help to regulate the system and to keep it in a comparatively stable set of climatic and ecological conditions over very long time frames. This idea is what lies behind the concept of Gaia. Many of you might have heard of the Gaia hypothesis. But even if people don't go so far as to think of the planet as one organism, it's important to recognize that all of the ecosystems of the planet interact together. And that interaction of all of the ecosystems on land and in the oceans is what provide the conditions necessary for our survival as human beings that are part of these global ecosystems. The idea of Earth as a system has been an immensely powerful idea for global change science, probably for the last 50 years or so. And this rather messy picture that I'm showing you right now has been one of the most important wiring diagrams or system diagrams, I would argue, ever put together in any field of science. Just to give you a quick overview, every one of the yellow boxes in this figure represents a research community in its own right. The atmospheric scientists, land ecosystem experts, marine chemistry, we all build our knowledge together in these different communities. And this figure is called the Brotherton diagram, and it was developed in the 1980s by the Earth Systems Science Committee of NASA, demonstrates how we can join the knowledge of these different communities together to have an understanding of how the whole system works. Every white box in the diagram is a global data set that allows us to see the flows and the exchanges and the energy dynamics that connect the different components of land, ocean, atmosphere, and the physical environment. The reason it's been so influential and so important is that it's provided the basis for almost all of the global systems models that we use now, climate models that couple the physical dynamics of the physical climate with the biogeochemical dynamics of life on Earth. What's really interesting from my perspective as an Earth system scientist is that it recognizes that human activities are important in shaping those dynamics. I mean, even back in the late 1980s, it was really clear that human activities were changing the dynamics of the Earth system, and that the changed dynamics will have impacts on human activities. But when it came to actually understanding and putting together the analytical tools and the global data tools and the models for understanding the Earth system, the scientists at the time were really forced to leave the human activities really in a small box on the outside of this elaborate wiring diagram, this elaborate systems representation. And that continues to be a huge scientific challenge for us now. This process of trying to understand how human beings change the system, and of course how we suffer the consequences of those changes, is really at the heart of 21st century science. Global change science is obviously a global initiative. It requires us to understand and to gather data from all around the world. The reality, though, is that we've got very large data gaps in some parts of the world. The pictures here show the kind of equipment that we might use to collect temperature and salinity data in the deep oceans, or carbon dioxide exchanges between vegetation and the atmosphere in land ecosystems. The FluxNet towers have been distributed in many places around the world and help us to put together our understanding of global carbon emissions and, of course, where the carbon goes once it's been emitted into the atmosphere. Another challenge we have is trying to piece together the story of environmental change over a very long time. And obviously, this is how we know that the changes that we see now, really in the last century or less, are so very big compared to the changes of the long-term past. And we have to piece together that, really like a jigsaw puzzle, we have to piece together the information about past changes. And sometimes we don't have direct measurements. Sometimes we have to use indirect measurements like tree rings, where the thickness of the dark bands and the light-colored bands in a tree, once you cut it across, tell you something about the temperature and the water conditions when that tree was growing. So with really careful interpretation, you can start to build up a pattern of past climates and, of course, major events like fire and other sorts of things. So when we talk about global change, we really are talking about the very detailed picture that individual scientists put together in their different knowledge communities, where the real task is in holding it together into one big picture of system change rather than just carbon change or temperature change. We're trying to understand the dynamics of all of those things together. And really, especially since the 1990s, when global sustainability became a priority for countries around the world, we've been able to piece together as a scientific community some very detailed pictures of global change. So here I'll just show some very quick pictures. The maps of changing land cover, where croplands have been expanding, grasslands have been converted to agricultural production for pastures, for example. And of course, one of the biggest concerns we have is about deforestation, where densely forested areas have been progressively fragmented or converted to other kinds of uses. These particular maps aren't very, very current. They're from about, well, over 10 years ago. And the situation actually is getting worse as time goes on. We're really transforming Earth's land surface in very, very large scale processes. I ought to just say as well that you can find more up-to-date information about these things through some other global networks that put together these global processes. So that's what the text at the top of the slide is about, the Global Land Project for land cover. The Global Water System Project over the last few decades has put together similar information for water flows and the changing water flows. We can predict environmental changes because we have data and models that allow us to see not just what has happened in the past, but what the implications of changes will be for the future. And water is one of these areas of very great concern. And I'm sure many of you know more about that than I do, really. When we look into the very near future, it's projections of water use are that more water will be used, will be taken away from rivers and groundwater systems. So water stress in many areas of the world is projected to increase. And in that context, the fact that we're changing other aspects of the environment is also becoming more of a concern. If you change land and you change water, you are changing the ecosystems all around the world, and you're changing what ecosystems are possible all around the world. I've taken this quote from the World Bank from a few years ago because it's rather unusual for the World Bank, or any bank for that matter, to over-exaggerate concern about environmental issues. Their focus does tend to be on financial issues very much. But in their report from a few years ago, they talk about how the loss of biodiversity on a large scale in the context of unmitigated climate change really would push the whole of the Earth's ecosystems into an unprecedented state, a state unknown in human experience. Ecosystem change is a really interesting challenge for us at the moment because we have so little data compared to climate change, for instance, where we can monitor carbon dioxide all around the world, and wherever we're monitoring it, we can make fairly clear and robust, have a very clear and robust insight of what the global concentration is. One of the challenges we face with biodiversity and ecosystems is that it is specific to the place. If I measure butterflies here, that doesn't say anything at all about dragonflies in another part of the world. We can't extrapolate from one place to another. So the fact that we have so many data gaps in our understanding of biodiversity and ecosystem change is a really big scientific challenge for the projections that we make of the impacts of climate change, for example. And the projections of climate change themselves are very alarming now. We've had 5 global assessments of climate change published since the early 1990s. And already in the first one, the science was very clear that human beings were changing the physical climate by burning fossil fuels and through deforestation. Every assessment report of the IPCC that is published gives a more precise story of how much warming we are causing, and gives a more robust set of predictions of how much warmer it will be. The latest one has a very detailed chapter on the detection of warming that's directly attributable to human emissions, human greenhouse gas emissions, and also what they call the attribution. We can statistically allocate responsibility for warming and climate impacts around the world. So this isn't a question anymore of a shortage of science. It's something about the way that the science gets transmitted into society that we really need to consider if we want to respond to the climate change challenges for sustainability. And that's really where I want to move to in this next part of my discussion with you. That we've got high resolution models and we've got very detailed maps of different aspects of environmental change, but really on their own, they are not enough to inform responsible sustainability action. And I suppose as a scientist, it's important for us to keep remembering that the communication from science as a knowledge community to the rest of society is not a one-way flow. It isn't enough just to write an assessment report for the IPCC and hand it over to the national government representatives of the UN Framework Convention on Climate Change. We really need to start understanding much better about how different sections in society can hear the messages that scientists are trying to transmit, but also how scientists can engage more actively with other groups in society, both to have a more detailed understanding of environmental change and to be involved more actively in the discussions about the social change that might be needed in response. So one of the things I've been doing is trying to translate the very complicated messages of science into much simpler messages that can be acted on by businesses, for example, and by communities all around the world. So here, the biggest message that comes out from all of the IPCC reports on climate change, from my perspective, isn't that the world is currently warmed by 0.8 degree of a global average temperature signal, but really that when you warm the planet by 0.8 of a degree Celsius, the whole of the climate system becomes less predictable. And we're already starting to see the implications of unpredictable environments, extreme weather conditions that really overwhelm some of the social infrastructure that we have in place. The message about changing ecosystems all around the world can be very difficult to transmit if you focus only on the language of biodiversity. But the clear, blunt message for business and wider society is that when you destroy living organisms and change ecosystems, change life, the whole world becomes less resilient to other kinds of change that are imposed on these ecosystems. We'll talk a little bit more about resilience later. I know that that's what the main focus of this whole course is. Similarly, we can present all kinds of complicated maps about food security and water resource availability. The really difficult message to get across to people is that there's no substitute for water. So when we interfere with water flows, we're creating vulnerabilities that weren't there before. When we take water from one place and redirect it to another, we shift the vulnerability of the community from one place to another. And we're really trying to understand, I mean, this, I would say, is one of the difficult areas of our research right now. We can often understand the direct impact of something, but increasingly we're starting to see that if you change ecosystems on a very large scale through, for example, deforestation, you change the water flows through the atmosphere, you change where it can rain. And again, that affects ecosystems somewhere else. That's very different from the old challenges where we would just put a dam on a river, and so the deliberate choices of where you put water and where you redirect water have a very different set of consequences. Different consequences from if the Earth's own responses to changing water flows. And we've got a whole lot of other things that human beings can do now through technology and innovation that our ancestors couldn't do before. We can make chemicals that are so toxic and so hazardous that they simply should not be released into the environment at all. One very clear example of that is the CFCs, the substances that destroy the ozone layer. All the way through the 20th century, they were used very freely, really, with the beginning of refrigeration and the beginning of different kinds of industrial production. And it took a little while before it became clear that although they're not very hazardous to people as chemical substances, they are very hazardous to the planetary organism. They change the way that the upper atmosphere works. And so this is an example of what I call, and what many people now call, a globally systemic risk, where the immediate, local, or short-term risks might actually be very small. But it's the very large-scale risks and the impacts somewhere very far away or at a different point in time that we need to worry about. So back to the example of the CFCs in the 20th century, when we were making ozone-depleting substances without knowing that they were ozone-depleting substances, we simply had no idea how close we were to fundamentally changing the capacity of the atmosphere to protect us from dangerous solar radiation. We were lucky in that example because we've been able to sort of make industrial transitions and change the environmental release of substances, different kinds of substances, so that we no longer have the same threat to atmospheric chemistry that we did before. But if you're a business, for example, making new chemical substances, the message from science is that it's not enough just to do laboratory tests for local and small scale impacts of hazardous substances. We might also need to take a very big picture perspective and look at global changes and global risks. I've used the word risk quite a lot, and I think that really, for many of the global change issues that I've mentioned so far, there's already a very good understanding, both a scientific understanding and a policy understanding, that human-caused changes present global risks. So I just picked out 4 examples here of climate change, where we've got the Intergovernmental Panel on Climate Change and many other scientific assessments of impacts and vulnerability. Biodiversity loss and ecosystem change has become a major priority. The first global assessment was the Millennium Ecosystem Assessment in 2005. But the Convention on Biological Diversity and other policy contexts are really trying to understand ecosystem change as a global phenomenon now and respond to it in policy, through policy, like the Convention on Biological Diversity. Some of the other things are a little bit more complicated. So changing the patterns of nitrogen pollution or phosphorus pollution, things that are really tightly coupled to our global food production systems. These are issues that are only just becoming policy questions at the global level, even if in some parts of the world there have been local pollution problems for a very long time. The same is true for synthetic chemical pollution, the sorts of substances we normally think of, like agrotoxic pesticides and those sorts of things. So when we're talking about global change pressures, we have scientific information. For many of these issues, we have policy structures for taking the science and putting them into practice in society. But at the same time, we're watching the world changing so fast that both the scientific assessments and the policy structures are needing to respond and adapt in new ways. And I think the real challenge that we face is that our global pictures, if we're global scientists looking at the whole planet, we don't have a detailed picture of what's happening at the local level. Just the same as people really focusing on local level problems or risks and crises don't always see the bigger picture of global changes. And somehow we need to recognize that it isn't just a big, small, a challenge of moving from a big thing to a small thing, but really a challenge of taking a simple perspective, whichever scale we're at, and recognizing that it's a complex relationship. The same amount of climate warming will have very different consequences in different parts of the world. Just to give one example of how you don't simply treat this as a scale problem, but as a system problem. And that's the challenge that we face when we're trying to talk about planetary boundaries or the limits of human disturbance to the planet. There's a very long history of people talking about limiting the disturbance of human impacts on Earth's living resources. Thomas Malthus was one of the most famous European scholars a couple of hundred years ago, talking about the possibility that very rapidly growing populations would somehow destroy their own capacity to produce food. Much more recently, the Club of Rome in the 1970s did the famous limits to growth analysis, where they also said, if the current trends in population and industrialization continue, then sooner or later we will hit the limits. Those are both, these have been very influential stories of what will happen to our future as humanity develops. But they're very complicated. Well, they're so simple as interpretations of the impacts that they become not much use when we want to put them into application contexts. So one of the obvious challenges we have is that even if we're talking about global population change or global demographic change, the reality is a much more complex reality. We have rich and poor living side by side. We have people, even in a household, can have very different life habits with very different ecological consequences. So, speaking as a global change scientist, it becomes really difficult to have one big message about what the world should do in the future, recognizing this really complex and detailed picture of reality that we really live in as human beings. One of the areas of research that we're working on right now is really trying to understand how global trade adds many layers of complexity to our pictures of environmental change and also to our possible responses to environmental change. When we're talking about how to live sustainably, it's almost impossible now to think about living sustainably only where we live, because so much of what we do and everything, the clothes we wear, the food we eat, the way we do our jobs, the computer that I'm speaking to you on now, all of these things have been entangled as global, international, multi-ecosystem products and processes. So the social choices we make or the individual choices we make have local impacts, but also when we have, the local consequences of the choices that we make shape what's possible for us. And this leaves us all, scientists and normal human beings alike, with a real challenge of saying, what do we do? How shall we live sustainably? What choices can we make in such a complicated and complex, entangled world? One thing we know is that a resilience response to global change requires us to think across scales and across different decision levels of government, from national to local. It requires us to recognize the diversity of social communities and groupings. It requires us to think global when we act local, and also to think local when we act global. And those are all very new challenges, really, in the scheme of things. My grandparents didn't have the same kind of globally connected questions so dominant in their everyday world. For them, going to the next city was really a once in a decade activity, whereas now we live very differently, and the consequences of our choices are much harder to trace. So my main message for you all is really, when we talk about living sustainably within Earth's safe operating space for humanity, we have to go beyond the calculations of fixed limits. Although I think scientifically the task of questioning where those limits might be is an interesting task. The action that we take has to recognize that the safe operating space is dynamic. Our human choices change the position of limits. The interactions of the living world and the physical world also change the position of any limits that we might set on sustainability. And we also have the issue that our choices are sometimes limited. What is available to us in terms of resources and what is possible for us in terms of our life paths depends on where we are in the world and how we interact. It's shaped by the pressures that we face from the societies that we live within. And so the conversation about global sustainability really, if it's not going to be completely local, then it really also has to be a global conversation. And we've reached the situation really where global sustainability, or living in the Anthropocene, in some ways is very simple. We know exactly what needs to be done after 40 years of detailed science. We know that we need to halt the rise in greenhouse gas emissions so that climate change doesn't become a runaway problem. We know that we really should stop releasing pollution of different sorts, both the hazardous substances that only humans can create on an industrial scale, and also the substances that we don't often think of as hazardous, like nutrients, nitrogen and phosphorus, because when they enter the environment in an imbalanced way, they have implications and consequences for ecosystems that in turn affect us and our social systems. And we know that we really need to minimize the footprint of our activities. And here I'm obviously speaking as somebody who lives in an industrialized Western country. There are millions of people in the world who don't have big environmental footprints. And we're reaching the situation now in the world where our activities in the industrialized rich world is actually destroying the footprints of the people who don't have harmful footprints. So there's an ecological justice dimension in our sustainability, in our global sustainability perspective that we need to be aware of. And it's a complex picture that we're dealing with, but if we follow these 3 steps a little bit more every day, at least there's a little bit of hope that we can start to bend the unwanted curves of environmental change into something that might become sustainable. I think I'm going to drop it there. What do I have next? Yes. I've now got questions for you all, because of course, as scientists, we ask questions better than we come up with answers. And so we can present information that helps choices to be made, but we don't have the right answers for what should be done. So I really appreciate your experiences and your discussions in helping us to set the next scientific agenda for global sustainability.
Thank you so much, Sarah. This was a really interesting and relevant topic for our NBSAP forum members. I'm sure our participants found your presentation valuable for implementing their NBSAPs. And I would like to invite participants to share their questions, doubts, and comments, or raise their hands to participate in the Q&A session. Please use the control panel of the GoToWebinar platform. We can open your microphone or read your question depending on your preference. So we've already received a few questions, Sarah, so I'm going to read them to you. Is that okay?
Yes, that's great.
Okay. Well, we have a very interesting one that says, how can education help in an individual's and society's resilience in all aspects? How can it be incorporated without changing the curriculum? Have you considered, or have you had any experience working, with resilience and education. Have you had any projects dealing with that?
Yes, and well, yes, we have. One thing that I find really exciting is that we have just about completed the UN's Decade of Education for Sustainable Development. Up until fairly recently, I think many of us who are involved in education, I work in a university, so it's a rather high level of education compared to, we get a relatively small number of people coming through universities compared to the total numbers of people who get education. But I think many of us who were involved in the education sector felt frustrated and discouraged about the UN Decade of Education for Sustainable Development, because it seemed as though people simply hadn't picked up on the idea. But when we stop and look back, we realize that actually a whole range of different issues have become part of the education curriculum all around the world. And I know a little bit about the education system in Sweden and in the UK and in Europe, but also about Brazil, where I've got some colleagues who were working there on education for sustainable development. And we see that we've got environmental education becoming much more mainstream in school books and classes, and many other aspects. Now, obviously, sustainable development isn't the same as resilience, but the two have got a very close relationship. The two concepts have a very close relationship. We feel that, I mean, again, we do also work on education programs for resilience here at SRC. We've been involved in MOOCs like this one, trying to sort of provide information about global change issues and about resilience choices for an international community, but we also teach here. And we also work with communities all around the world, applying resilience ideas through resilience assessments, where we invite people in communities to think about their place in the ecosystems that are around them. So I think education plays a really important role. One, in terms of helping us to understand environmental processes as environmental processes, helping us to understand our place, our social and cultural place in the living world, rather than just in, I think this issue of understanding the living world is vitally important. And I think this is why I'm so enthusiastic with hindsight about the Education for Sustainable Development decade, because up until recently, it was possible for people to go through school without having studied anything about the living world. Whereas now, even if it's only part of their curriculum, it's become a normal part of the curriculum. Another aspect of this, I just wanted one final point, is the way that we're really talking about lifelong learning and the learning that comes from all different kinds of aspects of life. We've got a lot of focus at the moment on how we hold on to traditional knowledge, where the wisdom and often a very different world view of how Earth works or our environment works is actually very important for our understanding of our current situation. So holding on to the sort of the very broad range of different ways of knowing the world and making sense of the world is also an important part of resilience.
Thank you so much, Sarah. That was really interesting, and I think you thoroughly answered Kevin's question. We have a couple of questions submitted by Alberto Licayan, and I'm going to merge them because they're related. What are the barriers in cooperation for addressing the concept of risk in a changing climate? Is there political, financial, or collaborative will to really address the risks? How can we cooperate and contribute to address the concept of risk in a changing climate? So you see, they're all sort of linked together and gearing towards both the political and economical will for change, and also how can society collaborate in the face of a changing climate.
That's I'm glad it's phrased in lots of different ways, because actually it is going to be a complicated answer too. I focused on the words I wrote down were barriers and cooperation and risk. So, and I'm going to answer the question sort of in reverse order. The interesting thing is the way that the idea of risk has now become really a priority for the climate change science community. I think up until recently, they thought, I'm being a little bit dismissive in a way, up until recently, it was as though climate risk could be expressed only through statistics. So if we had a very detailed hazard mapping tool or a very complicated set of modeling tools, we would come up with a very well quantified story of risk. What's interesting is that people are really moving much further towards multi-dimensional understandings of risk, especially in relation to climate, even though climate science is such a quantitative study. So we're beginning to sort of understand the multiple sort of flavors or differences of vulnerability, and the fact that some people can be exposed to very high risk with relatively little environmental hazard actually happening. So there's sort of having a much more detailed understanding of what risk means, who's exposed to risk, and who's responsible for the risk. I think has come from really some very multi-discipline discussions, and again, discussions between policy and science and other sectors in society. So I think compared to a couple of decades ago, we see that cooperation happening, because it's really clear that national governments can know, they aren't assessing risk and creating risk management plans in the same way. There's partly, and we'll be pragmatic about this, partly it's because national governments in many parts of the world don't have the money to manage the risk anymore. Risks are rising, and so we need a much more social engagement in the process of responding to risk. You see that in communities where, I'm thinking particularly of flood risk issues, where you might find that kind of community cooperative responses are being encouraged, or because there simply isn't capital funding available for big concrete walls to protect communities against risks. We also see the shifting role of business, and I think that that's a very interesting question right now. Some sectors, like the reinsurance sector, has been very, very active in helping communities to manage their responses to risk, in a way almost bypassing national policy, but using these very different instruments like people's access to insurance cover. Whereas I think other companies, other kinds of sectors and industries have been contributing to the risk problem that we face from climate change, because there's no mechanism, no social or political mechanism for them to be accountable and responsible for the risks. So I think shifting away from thinking about the barriers to responding to risk to what it is that helps us to manage the changing risks that we face in the context of climate change, I'd say that global transparency and the information that we now have available help countries and country governments and companies to be much more accountable than they were before. When Facebook tells you about major mudslides and deaths, even though your national news doesn't, then I think we've got some really interesting dynamics for sort of understanding the exposure that people face to climate risk, and also for mobilizing society to respond to them. Does that answer the question? I keep saying it's just more difficult than it sounds.
Everything is very complex regarding this topic, but we really appreciate your willingness to answer these difficult questions. We are receiving many questions from our participants, and I want to thank you all for your enthusiasm. And but please be patient, because these are tough topics, and Sarah is doing her best to cover them all. These are really tricky topics, and your questions are very tough, so please be patient. We have somebody raising their hand. Janan Gora, I hope I pronounced it well. I'll open the microphone for you right now. Janan?
Hello. Good
Hello,
evening.
did I pronounce your name well?
Yeah, it's Janan Gaura. It's correct.
Okay, well, nice to meet you. Can you please be very straightforward and brief in your question to Sarah, please, so that we can have time to answer the largest amount of questions that we can.
I don't have a question, but for her question, can we answer it?
Yes, please.
Okay. So first, I will introduce myself. I am Janan Gaura from Iraq, and currently studying Master in Tropical Biodiversity and Ecosystem in Brussels with a program called Tropimundo. Yeah, so I will try to answer the first question, which say how we deal with urgent or systematic environmental issues. So for us as young, as we call ourselves leaders, what we can do some initiatives, like before 3 weeks. So I attend our Ocean Summit, and there we come with one idea of cleaning the beach, and it was like a 1 hour cleaning the beach in Malta. And there we clean, like in 1 hour we were cleaning, and the people were looking at us. And there's some people who were eager to know why we are doing that and what make us to do that. And then they come to us and talking to us. And even we make, while we were cleaning, a kid come and try to help us. And then we ask him why you are helping, why you are doing this. He say, I don't want the animal to become sick because of the plastic and like all the garbage in the beach or in the sea. So I think this is one of the activity that we can do it all as like it's very easy, and we can do it everywhere, and this will motivate other people and let them think that, oh yeah, this is the reason, and while having this plastic here will make this and this issue. So, and by this we cannot solve all the problem, but we can make some change, and that change will make the behavior of other people to be changed, and maybe it could make something change. Yeah, that's my answer.
I really appreciate that. I think many of us who have been used to being scientists in what people talk about as the ivory towers, in other words, science sort of separate from society, are really challenged with the fact that we need to act ourselves with the issues that we identify as urgent and systemic. So I appreciate your comment about, those of us in the position of leadership should actually start to lead. I think that's very, very important. I'm also very interested in the issue of plastic, because so many, for so long, all of us thought that plastic was just something that you throw away. And I think the issue of marine plastic is really showing us very visibly and very concretely that there is no away, even in the global scale. And I think there was something also that you highlighted that I want to emphasize as well, that there's a big difference between a sort of scientific knowledge, the sort of thing that you go to conferences for, and the real deep committed awareness, like the young people who came to join in. And so there's that difference between knowledge and awareness is something that really motivates me and other people like you, by the sounds of it, Janan, to really spread the word about sustainability. That, if we are globally connected societies somehow, we should be using that also for making a global response to urgent environmental issues. So yeah, thanks very much. I appreciated your comment.
Thank you, Sarah. We have several questions that have come in addressing the polarities or extremes and differences between, for example, poor people and rich people, developing countries and developed countries. And many people want to know who's to blame, who should act. For example, we have a question that just came up. In a context where global process has complex relationship with local contexts, how can island countries become resilient and survive? Because finally their survival depends on the liabilities of other countries. So this takes us back to the developing countries and developed countries. Another person says, if we divide the world into rich and poor, or into people who have easy access to all kinds of resources, and those who don't have easy access, who are the ones that are contributing most to this climate change? Can we divide the responsibilities of conserving and preserving the nature resources on these bases? More or less that's the question. So, if we divide the world into rich and poor, developed and developing, guilty and victim, how do you see this? How are scientists approaching this polarity? It's something that a lot of people are asking right now.
And again, I'm happy to say that scientists are also beginning to ask that too. I think that there's been one of the big areas of debate, particularly in the context of climate change, is why it is that so many scientists have been able to sort of talk about this sort of very abstract global change, and somehow keep outside of the discussion about who's responsible. And obviously in policy terms, we do talk about common but differentiated responsibilities. So there is, we've at least got a recognition that we need to recognize, and that's a circular story, okay? We have a policy recognition that blame needs to be allocated carefully and responsibility needs to be allocated carefully, but that's a very long way away from actually knowing how to make that allocation. I think another layer to my answer is that there's a really big difference between a country being responsible for something, and in a lot of these global issues and in global trade, we talk about things in terms of national statistics. Although it's the people within the country that that actually do the acting in the world, that actually are making the change in the world. And so one of the really big challenges now is that the old categories of rich and poor countries no longer reflect where rich people and poor people are. So our polarities aren't as simple to, we can't divide people into these global blocks the way that we might have been able to do before. I think there was another little layer to this as well. Oh, the historic responsibility versus contemporary action is another real dilemma. And what I'm beginning to see is that we are creating different forums for these kinds of issues. We still have the UN talking about big country level sort of responsibility sharing with the big multilateral agreements. We've got things like the Sustainable Development Goals, where all of the countries negotiated what matters most to them. And then that isn't an easy set of goals and targets to meet simultaneously. But it's definitely showing something about what priorities are for the short term, even if it's not the sort of sustainability forever. And we also see a whole lot of other much more dynamic interactions. I'm really struck by the international community of Indigenous peoples who work together wherever they are in the world to make sure that Indigenous voices get heard in the big policy processes, but also in lobbying processes for industry and business action too. So we're beginning to sort of see that the power to change the world moves in these different layers, and whenever one group is very unempowered, they get very creative about how to get power back again. So that's true both ways as well. We see mega corporations also holding on to power very firmly, and they operate on a completely different level from countries, as we see in many places of the world.
Thank you, Sarah. We have another person raising their hand. So excuse me if I don't pronounce it very well. Soundharajan Bankaru. I will open your microphone. Please be as brief as possible in your question. Thank you. Hello? Oh, I don't know. Maybe he's not ready to talk, I guess.
Can you hear me?
Hello?
Hello, can you hear me?
Oh, yes. Hi. Yeah. I thought we lost you there for a moment.
Thank you. My thinking is resilience is highly linked with how efficiently we are using the resources. So that means whatever may be the resource, maybe fossil fuel, water, land, or whatever it is. So to meet the people's need by very less disturbance of the ecosystem, that lies in the hands of how efficiently we are going to, we are utilizing the natural resources. That means if we add more and more resource efficient ways, then we can add the resilience, I think. Is this right? That's all my question.
Yes, it's right, but I'm also one of the concepts that comes up very much in resilience studies, and again, I think a little bit in resilience practice in the real world as well, is that if we design our systems, and you've been talking about our sort of resource use systems, if we design them to be too efficient, then they actually can become vulnerable too. We need to leave some flexibility in the system, some scope for what in the technical term they might call redundancy in the system, so that in the conditions of crisis conditions, the whole system doesn't fall apart. Now, you really brought up examples of resource use like fossil fuels and water. Water is a really good example here, where you don't want to do necessarily the optimal allocation of water to different sectors or to different parts of the landscape. You don't want that allocation to be too rigid, because you also need to allow water to be in the system for some kind of crisis situation. We're just beginning to have an understanding of environmental water flows. So in water system management, if all you focus on is the river flow channel, the river flow through the channel of the river, but don't also think about the ecosystems around the water and what they need it for, and the role of evaporation for supplying precipitation that will feed water back into the river, then you could end up actually by having a too narrow focus on efficiency at one scale, you create vulnerability at another scale. And I think that a resilience approach to resource management holds these multiple scales in mind at the same time, or the different kinds of contexts. In the energy context, I suppose the example would be if you're using renewable energy sources, you often need to create quite a lot of redundancy in the system there, because individual contributors to the energy mix might not be long-standing. I mean, with fossil fuels, we just sort of keep power stations running with a bit of a surplus all the time. But when we shift to renewables, that isn't so clear. What happens when it's dark? We need to then think about how we have an energy mix that allows us to build in some redundancy into the system, because each individual component of the system, even if it's working as efficiently as possible, needs to be part of the bigger context as well. But I'm sure that this discussion of efficiency and allocation will be a big theme in the later sessions of this course. Good question, thank you.
Thank you, Sarah. I'm going to read several questions now that are linked, and they deal with the limits that we have. For example, we have a person here, Farina, saying, aren't there also non-dynamic limits when we speak of the dynamic, safe operating space by society? So somebody else, Hania from Brazil, says, is it possible to make the changes in the time we have with the economical argument that we have seen? Francisco Cobos asks, looking at the need to take urgent action, do you think we can still rely on voluntary actions, or should there be some forceful measures taken to avoid depleting the planet further? And Abdi Fatah Ahmed asks, can we say that nature's capacity has already been exceeded in the case of biodiversity? So they're all linked together. Is it too late, basically, is the question that they're asking. Tough one.
It is. It's a horribly tough one. I'll start with the first one, because that's a good place to start, about limits that aren't dynamic, about using up stuff and finishing supplies of stuff. There's some really interesting discussions at the moment in the context of phosphorus, which is an essential nutrient element, and we need it for food production. And because we have such large-scale industrialized food production systems, we've been using mineral phosphorus as a fertilizer in many parts of the world. And mineral phosphorus is a finite resource. So I think when people talk about running out of stuff, that's one of the big contemporary questions that's a very active discussion now. It sort of echoes some of the discussions of peak oil that were very topical discussions 10 and 20 years ago. And I think we can learn something from the peak oil discussion too, that even for things that we regard as non-substitutable resources, in other words, the sort of resources where we can run out of stuff, it's so far the world's societies have been able to make really quite big changes to, when limits start to bite, social changes have happened in response. And obviously, this is what Herman Daly, the economist who used to work for the World Bank, would sort of say, well, yes, we used to have a big world. We're increasingly living in a small world where these resource constraints will increasingly bite. But then that takes us to the next set of questions as well. Have we run out of time to change? And the words that jumped out in that sentence to me is we. Who is doing the changing and who is running out of time? Who is facing the limits? In many parts of the world, people have already encountered limits and are living under sort of very difficult conditions. We've protected ourselves against the limits in the richer part of the world. So I think, have we run out of time to live sustainably has embedded in it this idea that we are all one. We are all going to experience the same thing. We are all going to be sustainable or unsustainable together. And I think this is, for me, why it's such a difficult ethical question that sustainability presents. All of human history has shown that we create divisions. And I get very depressed when I think about that, which is why I don't usually answer my questions for you myself. This also links to, should we take forceful measures? I have no doubt at all that when resources start to bite, somebody in the world will take very forceful measures. I don't know if it will be we who do that, if I will be in the we that has the forceful side, or if I'll be one of the others who gets forceful measures imposed upon me. And I think this is the big challenge, and this is why many of us who are involved in sustainability are starting to call for more urgent responses, because you don't even need to have hit the limits for violent-minded leaders to act violently. We see that all around the world all the time. History has shown it. The thing that makes me less depressed in some ways, in a funny kind of way, is that history is very, very long. Human history is very long, and Earth history is even longer. A book I've been reading recently is called Life, an unauthorized biography of the first 4 billion years. And it reminds us that there have been many, many species on this earth. And if it happens that humanity has created conditions that we as a species are not well adapted to, we will be extinct like other species have gone extinct. And again, that's a very depressing line of thought. But that might well take a very long time, and some other life will continue on this planet unless we do something really quite extraordinary. In that sense, we might get what we deserve as a species, which makes it all the more important that we as individuals start to think about who we is when somebody says we need to live sustainably. Sorry, that was a depressing response, but that's what you get when you...
Well, it is a very scary subject. I mean,
know.
it's a dreadful outlook if you see it that way. You know, if you look at it that way, if there's a limit, have we reached it? It's.
Can I be more positive too? Actually, because
Question.
one of the things that always excites me is that people are so very resilient. So even in situations of major economic or social disruption, you will find that there are some people who will do their very best to grow green beans on their apartment balcony in a city, or who will save their chickens and go out and make a little tiny garden wherever they may be, and continue to live and continue to share and continue to build community with whatever bit of ecosystem they have access to. And I think that drive for caring for each other in communities and caring for our ecosystems, the ones that we know sustain us, is also what will save us as a species. Because that's what humans have always done, alongside making big weapons to hit each other on the head with whenever the opportunity arises. We are bad and we are good at the same time.
But it's true what you said about the Earth living, having such a long life. Maybe we still have hope. We have somebody else raising their hand. This will be the last open microphone question. Please, Andrew Mampagale. If you can be really direct and brief, because we are almost running out of time for this webinar. I'll open your microphone now. Hello, Andrew.
Okay, thank you. Hello.
Hello.
Hello, I can hear you.
Yes.
Hello, I can hear you.
Okay, thank you. But I just wanted to agree with the one spoke from Iraq that in order to act upon the environmental issues, urgent environmental issues, that we have to act. Because so many times we are raining and we're having so many meetings, but after that, then nothing is being done. But what I believe that we have to stand up from our seats and work and go direct there and try to help the society. They say when we are trying to address situations like climate change or food security issues, we can't solve them by sitting around on the meeting or sitting around in the class and doing nothing. But we have to stand up and go out there and do what it is supposed to be done, like planting trees, which can save maybe on the food security issues or climate change issues. I just wanted to comment on that, and thank you for the good presentation.
Thank you for the really nice comment too, because I think that is also part of our personal responsibility in the context of global change, that we act where we are, because obviously that's also the risks and the vulnerabilities and the critical issues that need action will be different all around the world. And so doing what is needed where we are is an important part of leadership and of scientific responsibility and human responsibility too. So thanks for that reminder too.
Thank you, Sarah. We have two last questions. Well, there are several, but I'm going to merge them into two final questions. One deals with technology. We have Hayden asking, is there any new technology and products in this area? And Ziva asking, how can we best use technology to address environmental risk and vulnerabilities? What are your thoughts on the effectivity of the development of GIS mapping, etc., in identifying such risks and vulnerabilities?
As I sort of indicated at the start of my talk, I think it's absolutely vital that we use the best available scientific tools to help us to understand the real complexity of the world. And you know, so I'm absolutely amazed at some of the ways that well, I'm amazed at the immense power of global models and Earth observation systems for helping us to understand change. But I'm also increasingly interested in the whole family of things that you might call appropriate technologies. And in that context, I'm finding it really interesting how different citizen-led information systems can be coupled with GIS, geographic information systems, to really give that place-based, detailed story of what's happening. I think there's, you know, now that so many people have smartphones, we can gather information about social change alongside environmental risks and environmental change in a way that we've never been able to do before. So if you go back to the picture of the Brotherton diagram, that yellow and boxy picture, where when they made that 30 years ago, human data really barely existed. They didn't have the capacity to embed human and to sort of couple the same kind of understanding of social dynamics with the biophysical dynamics. I mean, ignoring the philosophical reasons about what you might do coupling human and biophysical worlds. But now we've got data that tells us how networked we are, and how connected we are, and what we use and what we do. We've got more data than we know what to do with. So I think that opens a lot of opportunities for change. But I think we also need to start thinking of the issue of social traps there too. If our efforts to be sustainable depend on immense energy demanding infrastructure to tell us whether or not we're sustainable or where we should be or more or less sustainable, then we're really running a new set of risks as well. So, you know, again, we need to look behind this sort of beneath the surface of the solutions, the technological solutions that are presented to us, to see what they really mean. What's the carbon footprint of having an immensely complicated technological infrastructure for monitoring carbon? It's, I think because these things, it's just like the problem of the plastic being thrown away. If it's not visible to us, we tend not to think about it until it's too late and it comes back to our beaches and our world, and it becomes part of the world that we see. I think that some of the energy and resource costs of some of the technologies that we are presented with that should help us to be more sustainable can actually lock us into unsustainable paths too. I wanted to just give one quick final comment. This is another version of the forceful interventions for sustainability. There's some very interesting discussions all around the world at the moment in the context of particularly climate change. The sort of, as people look at climate change as a really terrifying prospect, the suggestion that we should have geoengineering of some sort has become a scientific and a technical and a policy conversation in many countries around the world. And I personally don't like to get involved in those conversations. I'd rather shut my eyes a little bit, because it's very frightening, the sense that we are interfering with the world so much that we would want a technological geoengineered solution. So I was really happy a little while ago when I discovered a paper that says, instead of geoengineering the planet, which takes so much resource effort and has consequences for all of the world's ecosystems, why don't we bioengineer the human? We can reduce our footprint if we make ourselves smaller, if we make ourselves be able to see at night so we don't need electricity. We have these technologies available. And obviously, or rather, might not be obvious, but I think it's a spoof paper. I think it's a joke paper. But it really made me think that here we are as, you know, as scientists proposing these huge interventions in the world. And if it feels unpleasant to imagine ourselves being intervened with in the same way, would I want to be engineered myself so that my ecological footprint is smaller? Why am I proposing it to the world around me? I still think about that. So if anyone proposes to you that a big technology will fix the world, suggest that they apply it to themselves first.
Thank you so much. Thank you so much. It's really interesting, and the way you put it gives a lot of food for thought, I think, for everyone. Well, I want to apologize to all of our participants who sent their questions, and we have not been able to answer all of them. We have reached our allotted time, and I want to thank Dr. Cornell for your time and your willingness to answer all of these questions and to have this interesting discussion with our participants. Would you like to share some final remarks on the topic or any recommendations that you may have for our participants today?
I just want to thank everybody very, very much. I appreciate the chance to have to think about these things again, because so many of us are sort of so caught up in our everyday work. The opportunity to think about what our work means in the real world is a really important one. So thank you to all of you, and thank you for inviting me to be part of the online course, the webinar. I will send some little bits of information, including the reference to this article on bioengineering the human, just so that you have it, just so that you're interested. And I'll make sure that you have, if anyone has any particular questions, by all means, get in touch. I can't promise to answer absolutely everything, but I'll provide some resource materials through the course.
Oh, we can send you the questions that were left unanswered, and maybe we can prepare,
a little information sheet.
Right, like a fact sheet or something like that we can post on the MBSAP forum where our participants can see it on their own.
Yes, that would be great.
That would be very helpful. Thank you so much, Sarah. You have been great.
Thank you.
And our participants as well. They have been so active. Everyone has been amazing, and I just want to thank everyone else again and remind you that you can check our website, www.mbsapforum.net, to get the latest news regarding this webinar and the Introduction to Resilience for Development MOOC. There you will also find a PDF copy of the presentation and a link to the recording, which will be available on our YouTube channel. And stay tuned for our next sessions. For further information, also visit the MBSAP forum or follow us on Facebook and Twitter. Please remember to register or update your profile on our forum as well. The MBSAP Forum is a global partnership to support the development and implementation of effective national biodiversity strategies and action plans. It is hosted by the Secretariat of Convention on Biological Diversity, the United Nations Development Program, and the United Nations Environment Program. I'm Marcela Torres, and on behalf of the MBSAP Forum, I hope you all enjoy this session. Have a great day or evening. See you soon.